Hello and welcome back to Oxygen Not Included. This is course 2, in which we will be talking about power setups. As I said in the previous video talking about this course, we are going to be tackling the basics of different concepts. I won't say this every course, but this course is intended for people that just have gotten the game, want to get started. They're not, maybe, like me, numbers inclined. They just want direct, simple solutions. If there's an issue with any of these videos, like a correction that should be made, please provide that in the comment section below, albeit I say kindly. In today's episode, we will cover the following: power production, the issue of heat and carbon dioxide, staggering your sources of power production, the spine concept, and battery banks. So before we begin, there are a lot of different kinds of wires that can be used to power things, and we're going to overview them very quickly. This power line I have right here has powered so many things for my base. In fact, if you look at it, the potential load is 4,135 watts. However, this specific wire can only cover 1,000 watts. It is known as just a wire. And even though it can be made out of different materials, it will only be able to use up 1,000 watts. So as Frankie's cooking here, he's using 60 watts constantly. However, the microbe musher we built in the previous episode is currently not being used, so even though it says minus 240 watts, it is not being used. These refrigerators are being used at 120 watts and 120 watts. If these numbers tally up to above 1,000 at any moment, which is not great because then the wire is being overused and can start a random damaged area somewhere. This wire, on the other hand, shows that its current load is 1 kilowatt, about, and has a maximum amount of 20 kilowatts. To keep it simple, the basic wire that everyone will start out with, no matter what you build it out of, can only support 1,000 watts. And this one can support a lot more. The heavy watt wire can support more than the regular wire. So it's important to know this distinction and to make sure you don't have too many things being used on one specific line. Now that we covered that, we're going to lead into power production. That was kind of background knowledge that's good to have. Specifically with the coal generator and the thing that'll be before that, which is the manual generator. I won't construct the manual generator, but simply put, everyone will start out with this, and it is a very smart investment for when you just start out in the game. It will produce 400 watts, which you can easily use to power your microbe musher, as well as your oxygen diffuser. And on top of that, you can use it to power up a battery as well. Now remember, everything you build will influence everything else, like I said in the previous episode. So although this battery is in fact gaining charge and storing it, which is quite helpful, it is also off-putting heat. However, when you're starting out, the devices I just mentioned, the battery, the microbe musher, even the manual generator, they won't produce so much heat where it can be problematic. A simple setup would be having the manual generator, the battery, an oxygen diffuser, and a research station to get started. After the manual generator is constructed, it is good to research a coal generator, which uses coal. Later on, I will mention how you can automate this process through using the auto sweeper. But for now, we will just stick with the idea that a coal generator will use duplicate labor to deliver coal to power your base. A coal generator will support 600 watts of production, and it will produce 600 watts, like I said, but it'll also produce 20 grams of carbon dioxide and heat. What this means is, although it'll generate power for you and a great amount constantly, it has a negative impact of causing carbon dioxide. This means you will eventually have to come up with a solution to use that carbon dioxide in one of several different ways. There are many ways you can use carbon dioxide. Later on, you'll be able to generate power in different ways. One way that I like to use is a natural gas generator. These, through using natural gas, will generate power. Here's the natural gas. Will generate 800 watts of power. And when they're used, I'll show you real quick, will drip out straight down right here polluted water, which you can then use in any kind of means that you see fit. Just like with coal generators, and even to an extent the manual generators, it will produce heat as well. And it also will send out carbon dioxide, just like with the coal generators. This leads to the concept of staggering your power sources. Currently in my base, I do not actually use a manual generator. I've been able, so far, cross my fingers, to move to natural gas generators and coal. We'll go over the research tree more later, but two things that are really good to research include the smart battery and the automation wire. This is a very base level understanding of automation, but basically, if you look right now, my coal generators are not running. They're not running because the wire is red. If it is green, then they are running, like we see with the natural gas generators. I did this because my primary source of power is natural gas as I build up coal. You can connect an automation wire like this to a smart battery, and then you can create a high threshold and a low threshold. What this essentially means is when all of the smart batteries reach down to 30, the coal generators will begin working. But this won't happen currently because I have enough natural gas generators that are generating power to keep it above 30. This number is kind of arbitrary, the 30. I just chose it because I am creating a staggered system. So when I run out of natural gas, which will eventually happen, but then more will come because of the natural gas geyser. But when I run out, the coal generators will kick in and will power my entire base. These guys are hooked up to their own dedicated battery, which has a low threshold of 50. So when the power gets down to 50%, it'll kick on and then generate power up to 95%. And if the gas is gone, it'll continue to get lower down to 30%, in which these guys will then be kicking on. This is a concept that's very important. It's allowing me to build up coal and keep supplies going, or taking advantage of something that is, in fact, renewable, which is the natural gas. When you're starting out, you'll be transitioning from manual power to coal-generated power. So even if you don't have a backup like I do right now, creating this system right here, a smart battery with some arbitrary number, and this will also prevent these from constantly running, which we do not want specifically with coal generators, because at the beginning you will find coal in areas like this, and it is finite until you find a solution to produce more coal. So having them constantly run means you're going to run out. Now, what is a spine? The spine concept is to use a very strong wire. I use the heavy wire. There's an even stronger wire that you can use, but it uses more refined metals. but this one should be just fine for any basic base. It connects all of the power producers, like the coal generator and the natural gas generator, together. And instead of sending out this heavy watt wire to power the base, it instead sends it to power transformers. There are two kinds. The basic kind requires general resources like gold amalgam, and I believe you can make it out of copper. That's even definitely what you're going to find at the beginning. And copper is very useful. This is what copper looks like. And what it does is I have connected my spine, which is the heavy watt wire, to this part of the power transformer. And it allows me to send out a smaller amount of power out. These guys can send out 1,000, and these can send out 4,000. Hello, this is Future Sevens, just adding in something that I forgot before uploading. So with the power transformers, I mentioned that yes, they can provide 4 kgs worth of power. That is still true, but do not forget that the small wire that you take from it, the wire itself can only handle a max power. So you could put a heavy watt wire here, and then the small part, if you fed off of it with a regular wire, it can only handle 1,000 watts. If you fed off of it the next fancier one, the conductive wire, it can only handle 1,000 watt. 2 kilowatts. If you decided you could do this if you wanted to, but if you fed it off with it with another heavy watt, that's 20 kilowatts. And then if you really need to go up there, however, this is mostly used for a better version of the heavy watt wire, you could do a max power of 50 kilowatts. As you see in my base, my spine is made out of the heavy watt wire, and when I go and I power the individual things, I use the conductive wire. This does require refined resources, so keep that in mind. But I just wanted to pipe in and say that the wires themselves do have their own power limits, so keep that in mind. These allow me to send out a different amount of power in each and kind of act like a battery. Typically, you will use your spine to connect to a power transformer, and as it kind of visually shows a big spot to a small spot, it will then send out a smaller wire out. This allows me to diversify what powers what. Currently, this wire, which you can follow, and it goes right here, the potential load is really high. And so it would be in my best interest to create another power transformer, probably the bigger ones, so that I can send out more power on a wire that is, not as overloaded as this could be. And instead of the potential load being 4,000, I can cut that down to a smaller number. So basically, a spine has all of your power producers. You use transformers to send wires out to power different areas of your base. Later on, you can set these up to automation wires, or just go and click disable building, and that can help you shut down certain areas of your base if they need to be shut down. Alternatively, you can just find the wire and have them deconstruct it to prevent power from going into different areas. This can help in emergency situations. The last thing I want to cover in this course for today's episode is the battery bank concept. Simply put, you put a bunch of batteries in one area. Each battery loses power at different rates. So the battery right here loses charge over time. It loses it, I believe, the fastest. Yes, and then the jumbo battery which holds more charge than this one, loses it. Yes, it holds a lot more power. It loses it even slower. These lose charge even slower, but requires more refined materials. A battery bank allows you to basically store up power. It is important to add that your battery bank, which is connected to a heavy watt wire, should be on the same path as all of your power producers and should, for most cases, not be after your transformers. So for example, if we take this transformer, which powers up the jukebot, oh, I didn't know it was jukebot, the jukebot, I should not have a battery here. It is better to have it before the transformers. There's probably a more scientific explanation to what I'm about to say next, but the basic gist is this. My spine, which has my power producers, are going to generate power. They're just going to do that at certain levels that I've explained earlier. When they generate power, each of these, for example, generating 800 watts of power each, when they do that, they are doing it all at the same time. If the power caps out, or caps out very closely, any excess is still just going to be generated, and you're not really saving up on power. Creating a battery bank in which it has no automation, it's just an area of batteries, will help you when your generators are off. These will slowly be using the power from your transformers as you see it declining. And it'll just spread out your power more efficiently. To keep it simple, if I only had one battery, and even if I had all these producers, I'm not capitalizing on the amount of power being generated. Having a balance between the number of producers and the batteries is very efficient, so that way more power can be generated across several batteries instead of wasting power on only one battery. But keep in mind, the producers, the transformers, the batteries, they all influence everything. They can all produce heat. These guys can produce carbon dioxide. The natural gas generators can produce polluted water. All of these need eventual solutions. But for the time being, staggering your power can be a great way to save up on coal and to fuel your research for your ever-evolving base. And that'll be it for today's course. If you have any other questions, please let me know. If you have any things that other people should know about with power production, we're not done with power production, but this is just a basic understanding of it. Please leave a comment below, and I hope to see you in the next one. Bye.